right, today we're going to think about how you can use scale drawings and your understanding of scale to help you solve more complex problems. I basically threw you guys into this. I wanted to see what could you do if you knew how to use a scale drawing, if you knew how to use something that's like a map. And I was intrigued by the things that I got out. So first, we started with this number talk, and I told you I wanted you to do this mentally. I wanted to see kind of what strategies did you have that didn't need pen and pencil to compare these quantities. The problem is as follows. Two cities are 243 miles apart. It takes a train 4 hours to travel between the two cities at a constant speed, and it takes a car travels between the two cities at a constant speed of 65 miles per hour. Which is traveling faster, the car or the train? So this is what we need to figure out. Who is faster? And in order to figure out who's traveling faster, there's a few things we can think about. We can consider who's going to travel farther in a certain amount of time. We could also consider who could travel the same distance in less time, because that means that they're traveling faster. I saw mostly who's going to travel farther in the same amount of time. And I think that that was helped by the fact that it was a little bit easier to do mentally, thinking about the computation. So we knew that the train, could have just put T, we knew that the train is going to be able to do 243 miles, and I'm going to abbreviate that, miles, in 4 hours. So for the car, it would be really handy if we could figure out, well, how far could the car travel in that time? So we know that the car can travel 65 miles per hour. So if I was going from 1 hour at 65 miles up to 4 hours, so 65 mph, miles per hour, times 4 hours, because I'm going to do this 65 miles again, 65 miles again, we end up with 200 and, I thought it was 70. I'm hearing people were saying 60. Let's see. 60 times 4 would be 240. 5 times 4, yep, 260. 260 miles. So that means in 4 hours, the train can go 240 miles, 243, and the car can go 260 miles. That tells me that the car can travel faster because in the same amount of time, it's able to go farther. So that was a major strategy that I saw a lot of people using. I just want to highlight another strategy that some people were starting to get toward. It's a little bit more computationally complex, but I also think it's useful for thinking about speed. So we know that the car is able to go 65 miles per hour, or that is how fast it is traveling. Instead of comparing distances, now let's compare speeds. So we're going to set the car up. It's at 65 mph. So now we want to see if we can get to the train to something that we can compare. It can go 243 miles in 4 hours. So if I want to figure out in 1 hour how many it could go, I would need to scale that down. It's like simplifying a fraction, and we could divide by 4. I'm going to end up with about 60, and it would be 60 and a remainder of 3, but 3 out of 240, it's going to be 60 and a fraction. So approximately 60 miles in 1 hour. Comparing 65 miles per hour to 60 miles per hour, 65 miles per hour is greater than 60 miles per hour, so again, the car is going to be the faster one. So this version compared speed, or in the previous version, we compared the distance that you'd be able to travel. So this is where we starting to think about distance, speed, and time. And those are the three things that you really need to think about: distance, speed, time, when you want to compare traveling. So then we came to this problem. Mr. Peters decided he wanted to go on an adventure. He thought about it and landed on the idea of fishing for wolves, because we're going to Wolf Lake. So he hopped in a car and drove from point A to B on I-90 for 8 minutes. I-90 is an interstate highway, and the speed limit on I-90 is 55 miles per hour. Did Mr. Peters speed? So if we know we need distance and we know we need time and we know we need speed, we're missing some information right now. We have a time, 8 minutes. We have a speed that we would like to compare it to, 55 miles per hour, but we need to know what Mr. Peters was actually doing. So let's sum something up similar. So for Peters, we're going to say P compared to the speed limit, which is 55 miles in 1 hour. That's what miles per hour means, in 1 hour. We know that Peters did some number of miles in 8 minutes. And looking at this, a couple things to already start thinking about. One, like I already mentioned, we're missing miles. Two, we have minutes compared to hours. We're going to come to that next. But first, let's see if we can find our distance. So looking over here, we have a scale that we can use. It's up here, it's also niftily down there. We've got that this amount, and I've already kind of set myself up this, is going to be 1 mile. And I'm going to use that as an indirect measuring tool. Rather than using a ruler that has centimeters and inches, I can use this because I know that's already exactly 1 mile. So these are all 1 mile segments. I took those from there and just rotated them. So I've got 1, it's 1 mile. 2, 3, 4, 5, 6. Ooh, this one bends. So this is like 6 and a piece. So 7. And then 8. So if we bent this around, we would have about a 7, about 8. So we have about 8 miles here. So we're going to say we've got 8 miles in 8 minutes. Compare that to 55 miles in 1 hour. Is that the same? Is it different in some way? So people did a few things with this. They looked at the 8 miles in 8 minutes, and some people looked at what that means for 1 minute. They said, well, if he can do 8 miles in 8 minutes, that means if we divide both, we kind of cut this scale down by 8, he's going to be able to go 1 mile per 1 minute. You can go 1 mile in 1 minute. Well, that means he could go 55 miles, because we have 8, 8, 1, 1, 55 miles in 55 minutes. Or 60 miles in 60 minutes. And the reason I care about 60 minutes is because that is the same as 1 hour. So he's going 60 miles per hour. The speed limit is 55 miles per hour. 60 miles per hour definitely is higher than 55 miles per hour, because in 1 hour he's going to be able to go an extra 5 miles. Another way of viewing this was that if he can go 55 miles in 55 minutes, he's already hit the 55 miles of the speed limit, but in 5 fewer minutes, so minus 5 minutes, which also means he's going faster because he's traveling more time, he's traveling more distance in the same amount of time, or he's traveling the same amount of distance in less time than the speed limit would require. So, shame on Mr. Peters, he was speeding. Now the question is, what if someone else comes into the picture? Now we have Trump. Trump's got a helicopter. Trump decides he wants to also visit this Wolf Lake. But the way he wants to do it is he wants to take his helicopter. And in his helicopter, he does not have to deal with any roads, with any traffic, anything like that. He can just go straight from point A to point B. he can do this in 8 minutes as well. So he flies from point A to point B in 8 minutes. Is he going faster than Mr. Peters, slower than Mr. Peters, or is he actually flying at the same rate that Mr. Peters was driving? People looked at this and they noticed pretty quickly that this looks like it is shorter than the distance Mr. Peters has to go. It does not bend, so he doesn't have to go around any curves. He can go straight from A to B. To confirm that, you could use your mile marker and say, okay, 1, 2, 3, 4, 5, 6, 7. It's only about 7.5, because we don't end up with, if we did another one, we would end up past it. So he's only going about 7.5 miles, but it takes him 8 minutes as well. So now if we compare Peters to Trump, he's going 7 miles in 8 minutes. Takes him the same amount of time, but he is going a shorter distance. So we could scale that up if we wanted. We could say, well, in an hour, how much time would he be able to travel? But we can also just scale it down to in 1 minute. How much is he going to be able to travel? So if it's 7 miles in 8 minutes, if we want to get down to 1 minute, like we did with Peters, we could scale that down by 8. And this is going to be less than a mile per minute. So he's traveling less distance in the same amount of time. That tells you that he is actually going slower. And what was challenging for people about this problem was they wanted to use their common sense ideas about helicopters. Well, it's at a higher altitude. It doesn't have to deal with traffic. It doesn't have to deal with turns, so it's going to be able to go faster. That might be true in general, but in this case, he goes 8 minutes just like Mr. Peters does. So it takes him the exact same amount of time. You have to pay attention then to how far did he actually travel. And he only traveled 7 miles, where Mr. Peters was able to travel 8 full miles in that time. So when you're thinking about distance, speed, and time, it's first helpful to use your map and to use your map scale to find a distance. And then you want to see how can you compare distances, or how can you compare the amount of time it would take to travel. And that gives us those speed comparisons that we can use to say, were these faster, were these slower, or were they actually the same?